my fellow assassins, to another episode of the Dark Assassins Podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I've said it before, and I'll say it again, long live the Xserve. So we're going to talk about that a little bit more in this episode, but as a sneak peek, long live the Xserve. Now, with that out of the way, before we get into the trivia question, I want to bring light to an absolutely fantastic meme that I saw this week, and it was when you open your 2-week-old code for your reference, and then it's your code to you, and it's the Joaquin Phoenix meme from Joker, you wouldn't get it, which I don't know about you, but I found that to be absolutely hilarious because, well, first off, I've talked numerous times on the podcast about how important it is to document your code because the chances of you remembering what that code means or what that code does is pretty slim, especially if it's something that you come back to in a few weeks' time or a month's time or years or more. So that's one of the reasons why you definitely always want to document your code, because otherwise your code will give you the old Joker and say you wouldn't get it because you'll have no idea what the heck that code even does. So let this be a tip for you developers out there to make sure that you document your code so that you can, so that doesn't happen to you. And even if you think, oh, this is super easy and simple, I'll remember this, those are some famous last words. Just like, let me implement this feature real quick. Or it works on my machine. Let me know if you've heard any of these before. So yeah, but also it's good practice to document your code, because if you want to be a software developer, you are going to have to deal with other people's code, and people are going to have to deal with your code. So it's best to help them out and help yourself out by documenting your code. And I mean, for me personally, it's always nice to see when I pick up another developer's code and I see comments in there and I can actually figure out what's going on rather quickly rather than having to decipher the code line by line. And I guess another quick tip here is don't just document your code with comments, but also document your code with variable names. And that might sound a little weird, but don't make all your variable names A or X. Don't do that. If the variable you're creating is the time that say you're creating a timer to time the length of your program or something. Rather than calling your variable X, and making you have to think about what the heck this is doing, you could call it like timer or timer start or start timer, something like that that gives the impression of what the variable is referring to. So that is something that is also helpful, because at the end of the day, it's just a bunch of ones and zeros. So if you can give a name to that ones and zeros, it'll make you able to decipher what those ones and zeros are referring to a little bit easier. So nice quick little tip there for you. So with that out of the way, let's get into this week's trivia question, which for listeners of the podcast, this should probably be another pretty easy one for you. I've been really in the mood for giving you guys softballs lately, at least the dedicated listeners, and we're going to continue that trend with this week's trivia question, which is, what is the act of altering or manipulating data during transmission to gain unauthorized access or cause damage? So what is that called? So you if you've listened to the podcast long enough, you'll probably have a decent idea. And that is the trivia question for the week. Now, this week, there was kind of a late stage bombshell that kind of got dropped, kind of came out of nowhere, which is Apple decided to announce their Scary Fast event for this coming Monday, which is October 30th, at a really interesting time. It is at 5 p.m. Pacific time, 8 p.m. Eastern time. And you might be thinking that sounds a little weird, because it is. They usually do it, I think, at like 10 a.m. Pacific time, I think is usually when they do it. And it's usually, I think, on like a Tuesday or something like that. Like it's not usually on a Monday, and it's definitely not in the evening, like around prime time. But I guess Apple's deciding that they're going to try to compete with primetime television, which personally, I'd probably tune into the Apple event. I mean, I'm probably going to watch it anyway. But even if, but regardless, it'd probably be more interesting than a decent amount of primetime television. But anyway, this event is going to be an interesting one because we're going to be getting new Macs. Now, if you're asking how do I know that, well, if you look at the announcement on Apple's website, the Apple logo turns into the Finder icon. So if that's not a big enough giveaway, I'm not really sure what is. I mean, you don't have to be an Apple leaker or in tune with the leaks to see the logo for the event transition from an Apple logo to the Finder icon and see the connection that this is a Mac event. So I'm not Einstein here. I'm not like reading tea leaves to find something that may or may not be there. I mean, it's pretty much, plain as day. But it should be interesting because in theory, we should be getting the new M3 series of chips. Now, which ones and how many is, I guess, kind of up in the air. But we should at least get the debut of the M3 series chips. So I would expect at least the M3 and then possibly maybe even the Pro and the Max chip maybe. I guess we'll see. Speculation has been kind of hit or miss on what we're supposed to get. I think an iMac is has been pretty much, I guess, as definitive as you can get when it comes to rumors, which, I mean, makes sense. I don't think you necessarily, again, have to be reading tea leaves for that, seeing that the iMac hasn't been updated since... It's been over 2 years, I think. It still has the M1 chip, so it's been a little bit. So it's definitely time. It's probably past time, you could argue, that it got an update. But as far as other things, there's been rumors about maybe some MacBooks getting updated. I guess we'll find out on Monday. So that should definitely be interesting. But that is definitely something that I'm going to be looking forward to. And the one nice thing too is I guess on the one hand it's kind of nice that it's in the evening since I won't be at work then, so I'll actually be able to like watch it when the event's actually happening, which will be nice. But with that out of the way, I think it's about time that we get into this week's cybersecurity tip. So for this week's cybersecurity tip, one thing that I talk quite a bit about on the podcast is virtual machines and VMs. Usually it's in regards to my home lab and home labbing in general and everything enterprise. But VMs are an excellent use for testing software. It could be you're not quite sure what the software does, or you just want a sandbox environment to see if it'll break your system as far as compatibility goes. So it's something that you can do, like if potentially to see if it'll, if you're trying to run it on an unsupported system or something, testing it in a virtual machine. something that you can do. But the reason why I bring it up for the cybersecurity tip is because if the application you're trying to run, you maybe not got it from a semi-sketchy website and you don't want it to potentially destroy your computer and get infected with malware and viruses and all that fun stuff, which, first off, I do not recommend going to sketchy websites to download software, but if you happen to be in such a situation, a virtual machine is an excellent way to test the software to make sure it won't destroy your computer. Now, again, one thing you do have to be very careful of is your virtual machine's settings, because some malware is pretty smart. So if it detects that you don't have any kind of internet connection, it won't actually do anything, which could give you the false impression that the software you downloaded is safe when it's actually not. But here comes the issue, because if you give your virtual machine internet access, there's the chance that it could infect other devices on your network, which is less than ideal, shall we say. So there is a way that you can configure it to give the malware the impression that it does have internet access without actually exposing, the rest of your network and whatnot. So potentially one way you could do this is through a VLAN potentially. Other things you can do is give it it depends on which hypervisor, solution you're going with. You can do it different ways depending on the hypervisor. But basically you give it a network card, and you can basically simulate a network connection without it actually leaving the virtualized environment. You can I would recommend looking up how to do it if you actually want to get into this stuff. But another thing that you could do if you wanted to be super duper safe is, like I said, create a VLAN, for instance, that you connect your device that's hosting the virtual machine on, so it can't access anything else on your network, and just totally isolate it. That's another thing that you can do. So there's different ways that you can do it, but that is something that you do have to be mindful of, is certain types of malware that try to phone home to a server somewhere. If they detect that there's no internet access, they'll stay dormant. So that is something to keep in mind. Another thing that I guess you potentially would have to watch out for too is some malware just stays dormant in general for a while. So one thing that you do want to do is you want to extensively test the software, keep it running in the virtual machine for, I don't know, probably, I guess you could, it really, I guess, depends on your risk tolerance, I guess. But the longer you leave it in the virtual machine for testing, the more sure you can become that it doesn't actually have malware in it, because there are other instances of malware and ransomware that will literally sit on your system and kind of just lie low in the background and see if you're a worthwhile target to actually attack. So if depending on the type of malware, if it's a time-based malware that just kind of waits and sits to make you kind of think that this software that I just downloaded didn't cause a virus, it's something else. Then if you just, run it a couple times, then see nothing happen to your system, be like, all right, it's good, that potentially you could be not catching some malware, and you could think the software is clean, and then you install it on your system, and then it's a time-based thing, and then boom, you are now infected. So definitely, if you're doing anything with semi-sketchy stuff or getting software from semi-sketchy places, probably a good idea to throw it in some kind of virtualized or containerized environment just to test things out and make sure it's good and won't destroy your system and potentially your network. So that is your cybersecurity tip for the week. Now, I don't think it's a secret that I am not a fan of certain types of software-based security, specifically when it comes to things like locks on doors, because as a software developer, I know things can be exploited, so I want hardware-based locks. And I think just in general, we need more analog-based things. Now, maybe that's just me being biased because, like I said, I'm a software developer and I know how software works. It can have bugs, and those bugs can cause things to break, and then things you rely on don't work, and that's no fun. And I had a rather interesting experience this week. It wasn't exactly a nerdy thing at all, really. But my car battery died this week, and nothing worked, which you're probably thinking, yeah, no dip, Sherlock, your battery died. What did you expect? And yes, you are correct. But when I say nothing worked, there's a couple things to take note of. Because my car is fancy schmancy, and I don't have to be a plebeian and actually use a key to turn the ignition, and it's all electric based. It's not an electric car, but like everything is powered electronically. There's no analog really involved. Things don't work. So if you have an older car where you actually have to put the key in the ignition and turn it, if your car battery dies, there's a chance that maybe if you turn the key and try to prime the ignition or whatever, you could maybe get enough juice into the battery to jump it, and maybe you'll be good. But when your car is literally a button that you press to start or stop it, if there's no juice, car no go. So it won't work. But in addition to that, my car's doors are like a half frame type thing. So the best way that I can describe this without actually, showing a picture or anything, since obviously this is a podcast, is those glasses that people sometimes wear where the frame only goes over the top of them and the bottom is just the glass of the glasses? That's basically what my car's doors are with the windows, except the framing part is the bottom. So that weather stripping part of the door that most cars have with the frame built in, that's just attached to the car. So what my car does is when you open the door, the window will shift down I don't know, maybe a couple centimeters or something like that, so the door can freely open, and then once you close it, it goes back up to where it's supposed to be to make that seal. But because that's all handled by the electronics, when the battery died, that didn't happen. So I was honestly kind of worried at times that I was gonna break the window because it wasn't moving like it was supposed to. But anyway, that was only part of the issue, because in addition to the windows and whatnot being electronic, another thing that was electronic is the trunk. So I was literally locked out of the trunk, which technically I wasn't, but I couldn't actually open the trunk from the outside. And even on the inside, there is a button to press to pop the trunk, but because that's also handled electronically, that didn't work either. So the funny thing was, the new car battery that I bought was, guess where? In the trunk. So I was locked out of the trunk, but the funny thing is I wasn't locked out of the car because the car's doors are electronic. So when the car battery died, the car was just perpetually unlocked, which is obviously not a good thing. If your locks are purely electronic and battery-based and your battery dies, locks don't work anymore. I mean, you're just asking for problems. So another reason why we need some real analog locks here, so, lock and key, works without any kind of electricity or power. So I kid you not, in order to get the replacement battery out of the car, to replace the battery that was dead, I had to get in the car, put the back seats down, and literally crawl through the car in order to get the battery out of the trunk because the trunk wouldn't open. So, yeah, we need more analog because it's like you can get in the car even though you potentially shouldn't be able to get into the car, but like the trunk's secure, of course, unless you get into the car and then put the seats down and, crawl through it, which I guess on the one hand, that was a nice fail-safe by the auto manufacturer, that if your car battery did die and you had something important in the trunk, like, I don't know, maybe the new battery you were going to put in, you could actually still get to it. Now, obviously, you'd have to kind of work for it since you basically have to crawl through the car, but you could at least get to it. But the thing that really, I guess, concerned me overall else is the fact that the car was just unlocked. Right? Like, I had locked it before, the battery died, so I made sure the car was locked, but then when the battery died, the car was just not locked anymore, which I guess you could argue on the one hand is nice since you wouldn't be locked out of the car, which if your car's locks are purely handled by the battery, that's honestly a good thing, so you don't get fully locked out of the car. So in that sense, like, it makes sense that the car wouldn't, lock with the battery dead. But at the same time, it'd also be kind of nice that if for whatever reason I had to leave my car while I, go get a replacement battery or something, I wouldn't just be leaving it unattended, unlocked. I mean, I don't think you need me to explain to you why that's a bad idea. Just like I don't think you need me to explain to you why it's a bad idea to leave your doors of your house unlocked, or why it's a bad idea to have weak passwords or no passwords at all on your accounts. I really don't think you need me to tell you why that's a bad idea. So the other thing of it too is my car's key fobs. They actually have like a little key thing, which I think is mainly just for the glove box. But like there's technically still a physical key component to it. So it would be kind of nice as like a fail-safe to have some kind of physical lock for the car that you could actually, lock it and unlock it. But yeah, so I guess on the one hand, it's nice that they put that fail-safe in place, that if your car was locked when your battery died, you're still able to get into it, because if they didn't put that in place and your battery died and there was no way to activate the lock anymore and you were just locked out of your car, that obviously wouldn't be a good solution either. So I guess they were kind of stuck between a rock and a hard place, but as we kind of discussed, there's kind of a way that you could get around it. But anyway, that was some interesting drama, way more excitement than I needed. But yeah, so more analog, please. Especially like the electric cars these days are kind of even worse because, at least in my opinion, because at least on the inside of my car, while basically everything is electronic. At least there's like actual legit buttons, toggles, and switches. Unlike, Tesla's, where if you want to change how much air is coming out of your vents, you have to go in through the touch screen through a submenu, or if you want to change the direction the air of your vents blows, you have to go into a menu on the touch screen to like drag around the thing. I mean, I feel like that's just asking for problems, because if you're constantly having to look down at the touch screen to like configure basic things about the car, I feel like that's just an accident waiting to happen. Whereas if you're, have a car with some analog, like actual vents that you can move yourself, or toggles that you can, select for the AC or your hazards or drive modes, or heaven forbid, you actually have a legit, handbrake that you can pull if you need to, or an actual gear shifter. Being able to do that without having to look, and just being able to do it by feel based on the actual analog buttons and switches, at least in my opinion, is a little more safe than having to be constantly looking at a touch screen to do all that. But I guess if you are a Tesla owner, you may or may not have one of those fancy-dancy self-driving features, which my car definitely does not have. So in that case, your car could just be doing all the driving for you, and you can be focused on the more important things, like making sure the airflow is just right, and controlling all that stuff. But jokes aside, I definitely would like to see some more analog come back to cars. Maybe we don't necessarily need to go back to the days of crank windows where you had the crank on the side that you had to where the term roll down your window comes from, because you literally had to crank and roll it down manually. Maybe we don't have to go all the way back there, but at least having maybe some manual locks on the doors would be pretty cool too, because there are other cyber attacks out there where people can intercept the frequency of your key fob for locking and unlocking your car, and spoof it and basically unlock your car that way without actually having your key fob. Pretty spooky stuff. But again, if you had manual locks, you wouldn't have to worry about that. But then you'd have other people on the other hand say, well, if you actually had manual locks, someone could come in with a lockpick set and maybe actually lockpick your car and get in that way. So there's definitely valid points on both sides. But being more of the software mind, and kind of knowing how some of this stuff works, I kind of would like a little bit more analog. But, that's just me. But that aside, I think it's about time we get into what nerdy stuff have I been up to this week. So I guess I will just say this. If anyone is curious, yes, the Xserve can run macOS Sonoma with Open Core Legacy Patcher, and yes, the Lights Out management function still works, even on the latest version of macOS. So yeah, that's what I was up to this week. Well, part of what I was up to this week. I decided that I wanted to try to upgrade my Xserve to the latest and greatest version of macOS. And I've been monitoring Open Core Legacy Patcher, been checking to see the supported models and whatnot for macOS Sonoma. And I finally decided this week that I was going to upgrade the Xserve. And finally got around to doing that. And one thing that I guess I will let you guys know, if you are running Open Core Legacy Patcher, whether it's on an Xserve or a Mac Pro, Mac Mini, MacBook Pro, MacBook Air, any unsupported Mac, if you have not updated your root patches in a long time, so those being graphics drivers or network drivers or things like that to give functionality back that Apple removed, there is a chance that when you try to upgrade those, you will run into some kind of KDK authorization error, which the KDK is the kernel debug kit. You potentially could run into an issue with an authorization error trying to install those. And I ran into this issue with my Xserve. I think the last root patch I had installed was, I think, 6.1 for OpenCore. And I saw this issue actually a few months ago when I was trying to upgrade from, like, I think Ventura 13.2 to something else, 13. I don't know, 5, 6, something maybe, I don't know. But I ran into the same issue, and I just assumed that it was maybe a bug with OpenCore itself and it would be fixed in an update. And then when I saw on the GitHub page that the 2.1 and 3.1 Xserves were fully compatible with macOS Sonoma, I figured, okay, so maybe whatever issue I was having before, maybe they fixed it. But I still ran into the same issue. And the reason why I didn't uninstall the root patches originally was because I was honestly kind of nervous that if I removed them, I wouldn't be able to get them back, and that would just make the system basically unusable, which, in fairness, I rarely use well, first off, I rarely use the Xserve anyway, because of how loud and how much heat it puts out, and there's a lot of reasons why I don't use it, power draw, but even when I do use it, I almost never use the graphical user interface at all. I pretty much never actually use the desktop. Occasionally I do, but pretty rarely, since most of its use case now is acting as a backup for my NAS, where I can, I've mentioned it many times, and that's mainly the main use case. I have occasionally used it as a macOS build environment for building code. I have an Ansible playbook set up for my video game that I'm making, which we'll get into in a little bit here, where I have Ansible playbooks set up to basically automatically deploy and build, well, not necessarily deploy, but automatically build my source code for the different operating systems, package it up, the release versions, and basically send it back to me. So I don't have to worry about logging into a Linux machine, copying the code, building it, putting everything in the proper directory structure, archiving it, and sending it back. And then the same for Windows and Mac OS, and that's just way too tedious. So I wrote an Ansible playbook that does it all for me. So for the Mac OS portion of it, I had set up the Xserve as basically that Mac OS build environment. Now, obviously, it really doesn't get used, I think. I used it initially when I was testing the playbook just to make sure it worked. But since then, I've used it maybe like 5 or 6 times. Like, I really haven't used it much at all. Mainly because I think partly also the main reason is I do the vast majority of my development for the game that I'm making on a Mac anyway, so I don't really need to use the Mac Ansible playbook to automatically build and deploy, because in my make file I already have all the rules and everything to make the archive version, the packaged builds for macOS, Linux, and Windows. So I can just run the rule in the make file to make the package for macOS on the Mac that I'm building the code on anyway. So I generally don't use it. But also because just how loud it is. But anyway, where were we? Yeah, root patching, right. So the reason why I was hesitant before was because I didn't want the graphics to basically lose the ability to have accelerated graphics. Because anyone that has used OpenCore and has tried to use their Mac without the root patches installed knows how basically unusable it is with how slow and laggy the graphics are, because there's no native graphics driver. So I didn't want that to happen, so I was a little nervous to uninstall the root patches. But I decided that, if I'm going to be upgrading to Sonoma anyway, basically all these patches are going to get absolutely obliterated anyway in the upgrade, so it probably really doesn't matter. So I'm just going to revert the root patches and try to install them again. So I reverted the root patches, tried to install. Obviously it didn't work because I didn't reboot it. So I rebooted it. It came back up, and the graphics were horrible. It was basically unusable. And then after dealing with all the lag, I reinstalled the root patches. It actually worked this time, gave it another reboot, and everything was back the way it should be. So, helpful tip here for anyone using old versions of the OpenCore root patches. If you run into issues with like KDKs not installing properly or getting some kind of authorization issues, remove the post-install root patches, reboot your machine, and try to install them again, and that should fix your issue. At least that's what helped me fix the issue. So yeah, helpful tip there. So I guess the other thing that I do find a little funny about the Xserve is the Xserve that I have, I've mentioned before, is a 2.1, which Apple, the last officially supported version of macOS was macOS 10 Lion, which I believe came out in 2011, 2012, one of those two. I don't remember the exact date. Yet here it is, running the latest version of macOS in 2023. And the other funny thing about it, too, is now my Xserve, which is my oldest Mac that is actually capable of running any kind of newer version of macOS through a patcher. I do have an older Mac, which is a black MacBook, but it's due to its CPU, it's not even supported under OpenCore, so it has no chance of running the latest version of macOS. But my Xserve is literally the oldest Mac that I have that's supported with OpenCore, and is also my least used Mac that I have. Yet it is also the most up-to-date Mac that I have as far as software goes, because all my other Macs, I'm still on Ventura and whatnot. I'm still like updating them with Ventura. I just haven't made the switch yet over to Sonoma, which I do plan on doing at some point, but I've been kind of holding back just because it's not like, because now officially no Mac that I own is officially supported under macOS Sonoma, so I have to go through the whole OpenCore process, which in order to either upgrade from a previous version or just install it in general, you have to create a boot USB, plug it in, and basically go through the whole install process like you're installing from scratch, but you can go do an in-place upgrade. But still, it is kind of a process and tedious. It's not like on an officially supported Mac, where you can just go into like the settings and go to the software update and click install, like update to Sonoma, and it'll just do it all for you, and you can just kind of set it and forget it. There is a little more like involvement that you have to be in. So it basically, I guess, just comes down to me being kind of lazy, I guess. But anyway, that is the Xserve. It is still alive and kicking. It is running the latest version of macOS. Lights out management still works, and it is pretty dang awesome. So I said it before, I'll say it again. Long live the Xserve. So I also mentioned my video game, and I did make some updates to that. Specifically, I got back to working on the bane of my existence, that being graphics. So I'm at the point now where I have a decent amount of the back end written that I feel like I should probably start trying to implement the back end with a front end. So that's kind of what I set out to do this week. Now, it's not fully implemented. Quite honestly, I don't think it's really all that close. But I did make some progress. So what I was trying to do is connect the battle system to an actual front end, because right now I have a test case that I can run that simulates like the properties of a battle and can kind of go through like the turn-based stuff and doing damage calculations and all that good stuff. But it's all terminal-based, so everything just kind of gets printed out in a wall of text that you do get to manually input like what move you want to select and whatnot, but it's just kind of a wall of text. So what I want to try to do is get a front end to that, I mean, obviously eventually I'll have to do it anyway, so I figured that this would be a good place to kind of start. So I did make some progress on that. And basically what I first started to do was just create a generic scene, which, seeing that I don't have any kind of like game engine or anything, literally my game engine is I write some code, hit run, see how it looks, shut the program down, edit the code, run it again, see how it looks, shut it down, edit the code again, run it again. So it's very inefficient. And I definitely could probably come up with a more efficient way, but quite honestly, I don't feel like spending the time basically creating an entirely new program just to help me write my current program. Now, if I was actually a little more serious about this, that's probably something I should do, because it would make my life a heck of a lot easier. But like I said, I don't feel like really putting that kind of time investment into it, which, I don't know, might come back and bite me later, especially when I remember how much of a nightmare it kind of was having to manually create the one demo map that I made. Like, that was kind of a pain. So it probably would be beneficial to have some kind of tool to be able to do that automatically for me, but I don't know, maybe I'll get around to it, maybe I won't. I don't know. I guess we'll see. But anyway, I got the basic kind of layout for what the interface for a battle will look like. So that was the first step, and I got that working. And then the second step was to actually start kind of tying in the back end into this. So unlike the hard-coded map stuff that I was doing, where I was having all kinds of issues with like resizing. So if you tried to resize the window, it basically wouldn't really work. I mean, it kind of would, but it would kind of mess things up. But since this view is basically a static view, it made resizing things a lot easier and more seamless. I still have to work on how I want to do the text rescaling. I haven't really quite figured that out, but also at the same time, not all the text is fully implemented anyway, so I guess I will continue to work on that. But a couple other things to note that I got working was I got an arrow selection working, so you can actually now use the arrow keys to like navigate around the interface to actually select things, and to go to the different kinds of menus and whatnot. And I also have some super basic at this point implementation of back end into the front end, and basically that just being I created a dummy Pokemon to be in the battle scene, if you will. And when you click on fight, it'll show all of its moves. And then when you select one of the moves, it'll say that it used that move, and then it'll have the PP counter decremented by 1. So actually kind of doing some integration with the front end and back end. And that was pretty much it. And that was a few days worth of work. Granted, it was only maybe an hour here, hour there kind of thing. It wasn't like I spent 8 hours a day for like 5 days working on this. It wasn't anything like that. But I was honestly, like, if I'm being honest, I am kind of surprised how much progress I made with this graphics stuff, because like I said, graphics are kind of the bane of my existence. But then again, there's the really only way that you can get better at something is by keeping to work at it. And that's really the only way that I'm ever going to get better at graphics programming, is by just continuing to work at it. And one other thing that I guess I kind of noticed in all this, which I guess I'll pass along as some advice to any new programmers out there, is one thing I've noticed over the course of my development career is I'll tend to not like something that I don't know or don't understand. So if there's a programming concept that I don't quite understand or don't really have a grasp on how it works or why it's used, I'll generally tend to not like it. And this is true for a bunch of different aspects of programming. Graphics was kind of part of that, although I don't know, maybe I'm coming around to it. Bit shifting was another thing that I didn't like and didn't understand, partly because I didn't understand it. And just in general, C and C++, I used to hate. I did not like them at all. And I came from a Java background. Java was my first programming language. So to me, having to do all these pointers and this memory management, I did not like it at all. Which is kind of funny, because if you've listened to the podcast at all for the past, pretty much I guess since its inception, I've talked a lot about C and C++ and memory management and optimization and why I love it so much. And I've basically done a complete 360, because I actually took the time to really start to learn and understand the language, partly through this game that I'm programming. It was kind of one of the goals of it. There's been a lot of goals for this game, but one of the goals was just to get better at C++, because it's something that I kind of wanted to try to strive for. And over the course of doing it, I've come to really appreciate and enjoy using C and C++. And it's kind of gotten to the point now where if you asked me like 4 or 5 years ago to write a program in some language, I would basically always just do it in Java. Java was basically my default. But since in the past couple years now, I pretty much am defaulting to like C or maybe even C++ to write programs in. And it's just mainly because I have an understanding now of how it works. And that's, yeah, so and it's not just programming that I've had this kind of same experience with, where I don't like something if I don't understand it type of a deal. But obviously, since this is a software development / home lab / technology themed podcast, I figured that was the most relevant to talk about. So that's why I did. But I guess diving in a little bit deeper into the front end GUI here. So I talked about, the arrow selector, and you can select different options between the menus and whatnot. And basically the way that I implemented that, and really just in general how you'll do like kind of graphics-based programming, is through the use of state machines. And that's basically kind of what I did to implement at least the preliminary implementation of these menus. So if you're wondering what a state machine is, basically the TLDR is it's just a massive switch statement. But if you are currently in or have earned a computer science degree, you're probably familiar with the term state machine. And if you're not, well, I guess first off, it's that thing that where you had all the circles with like maybe the letters in them, and then you had all the arrows pointing to the different circles. But if you don't remember, it was probably in your theory or foundations of computing class. But if you don't remember, I honestly can't blame you, because you're probably asleep anyway, because I don't know about you, but those types of theory-based classes when it came to computer science were quite honestly snooze fests, because to me they were always the outlier where, like, at least for my undergrad courses anyway, pretty much every computer science class I took aside from that one, there was some kind of like programming aspect to it. There was some kind of like actual writing code aspect to it, but that was all just like theory and math and numbers, and quite honestly, like, I'm sure probably some people fell asleep, and other people just elected not to show up to the class, probably because they didn't enjoy it. But anyway, that's where that came from. So that's kind of where state machines is kind of like a foundation of computing, I guess, if you will. But theory aside, actually getting into practical implementations, which is the only way that I kind of, quite frankly, am able to learn and enjoy computer science, is the actual implementation aspects of it, because reading textbooks when it comes to computer science to me is kind of counterintuitive, but that's besides the point. So basically the idea of a state machine is you identify what state you're in or what point of the program you're in, and then perform certain actions based on either user input or actions that occurred in the program. So basically you're kind of in this reactionary state. So based on actions in one state, you can move to a different state. So if we go back to the example that we're talking about here, the Pokemon game example, so we're talking about graphics in this case. So you'll basically, how I went through and implemented this state machine is I basically had a state for each one of the potential, I guess, views or states or menus that would exist. So you would have the choice selection state, which is where you want to select, do you want to fight, go to your bag menu, your Pokemon menu, or do you want to run? So that would be a state. And then if you hit fight, then you'll have another state, which is what move you want to select to use. If you select the Pokemon state, that will take you to the Pokemon menu, and that's its own separate state. Similarly, the bag menu would be its own state, and then run would also be its own state. So those were the main states, and then of course, once you selected a move, there would be one or multiple states after that for actually handling the actual turn that would go on, the animations that would occur there, that kind of a thing. Theoretically, I haven't gotten to this point, but you would have another state like in the very beginning of the battle, kind of setting things up. That would be a state before you even get to the choice selection menu. And then when the battle ends, that would probably be another state. So basically, the different points in the program, and then how you would switch between those states is, in this case, by the arrow selection menu. So when I select the fight menu and hit enter, or the whatever I end up deciding to be the A key essentially, that would transition you to a state, and then once you select a move, that would transition you to a different state, and then once the animations and battle turn has completed, then that would transition you back to the state you originated in, which is the choice selection state. So that's basically kind of a look into how a state machine would kind of work. So if you wanted to go back to the theory of foundations of computing class, basically those would be your circles, and then your arrows would basically be I hit enter on the fight menu and I go to this state, and then I selected a move, so then I go to this state, and the turn completed, so now I go back to the choice state. So that's kind of a little example and overview of kind of how a state machine would work. But again, they don't have to be action dependent. So they don't have to be, okay, you clicked on this menu, so now you're going to this state. So in the example that I just gave, that would basically be the battle turn, right? So if you've ever played a Pokemon game before, once you select a move, things just happen. And then after those things happen, you go back to the choice selection menu. Now, there's really nothing necessarily involved on your end. There's really nothing necessarily involved on the back end. Really, the only difference is you either go to the choice selection menu, you go to the Pokemon menu, like if your Pokemon faints through the course of that turn, or you exit the battle because either you lost or you defeated your opponent or the wild Pokemon, or you caught the Pokemon or whatever. So those are basically kind of your three main states. But during that course of action, the main state that'll probably occur is purely time-based. There's no input at all based on you. There's no input from like the game itself saying that a Pokemon died, I need to go to this state, or I guess it didn't die, right? It fainted. Got to use the proper terminology here. Or you caught the Pokemon, so the battle's over. But so the general, I guess, more often than not, I guess, if you will, I guess unless you're like a powerhouse just sweeping through everyone, is a battle state will happen where you select your next move that you want to do and you go on your merry way. The battle didn't end, you don't have to switch your Pokemon out, etc. So that would just basically be a time-based thing where you're basically just waiting for those events to play out through the course of the turn before you can then select what you want to do next. So things in state machines don't specifically have to be action-based. They can be based on other things like time, for example. So when it comes to these state machines, you can kind of see how it could be just one massive switch statement, because you're basically checking to see what state you're in, and then based on that state, you do some action. So one issue that you will find is if you do make it one massive switch statement, you might find yourself in some kind of nested nightmare. Whether that's curly braces if you're using a language that uses curly braces, or you're using tabs like for Python or something, you're gonna get pretty gnarly pretty quick when you're basically doing everything in a glorified massive switch statement. So you don't have to do this, but my recommendation would be that you put these things in functions, because it would make your code a little bit cleaner, and so you don't have all this nesting going on. But actually, on the topic of nesting, I believe the Linux framework has I believe in like their coding guidelines or coding standards, they have like a rule in there. Maybe it's not necessarily like a hard rule, but basically if you have more than, I think, I think it's 3 layers of nesting. If you have to go to a 4th layer of nesting, you shouldn't do that and instead make a function, which I think in general is pretty decent advice, because if you have that much nesting going on, there's probably a good chance that you're performing something that should be in its own function. For example, if you have something in an if statement, and then that's in another if statement to do some case, and then you have another if statement to do another case, and you have multiple layers of nesting here, you could probably just move that into a function, which is kind of where it comes from. But the other thing is it makes the code just makes the code a little bit neater, because if you have one of these massive switch statements, depending on how many states you have, the switch statement already is going to be extremely long. So adding a bunch of code just natively in the switch statement rather than functions is just going to make it even longer. So that's another reason why putting in functions could be helpful. So if you want to actually see what's going on, you can just jump to that function and see what's supposed to happen. The other thing, too, is it makes your code a little more readable, not only because you don't have a ton of nesting going on, but if you remember to the beginning of the podcast about documentation, not only can you write comments and name your variables good things, but you can also name your functions descriptive names as well. So if you have this massive switch statement and you're using descriptive variable names for, say, your enums that are each one of your states in your state machine, and then based on those states, you call functions with very descriptive names telling you what you're doing, that can give someone looking through your code at a very high level, going through your state machine, they can almost instantly understand what the heck you're trying to do without really ever looking at any of your code behind the scenes. So that's another way that you can also improve the readability of your code, is by adding descriptive function names. So that is one thing that you don't have to do with state machines, but it's definitely something that I would recommend you do just to make your code a little bit cleaner. So yeah, that's basically kind of state machines in a nutshell. So yes, if you are sitting in a theory of computation or foundations of fundamentals of computers, or basically all that theory stuff that basically I think a lot of computer science students dread and kind of fall asleep in, just write your own video game. I know that's definitely a lot easier said than done, but that would actually give you some real-world experience of actually implementing state machines in your actual programs, and can kind of give you a better sense of how they work, because as I've said many times on the podcast, just because you know the theory behind something, in my opinion, doesn't actually mean you know how it works or what it is, unless you've actually implemented it and know how to implement it. I said not too long ago, a couple episodes back, how I was the exact same way with VLANs, could tell you basically everything about them, how they worked, but in reality, I never was able to implement them, couldn't implement them. Every time I tried, it did not go well. But recently, I hit a breakthrough, and I was able to get them working and implemented. And the thing of it is, when you finally have that moment where you implement something, specifically we're talking about like a computer science or home lab situation, whether that's you finally implement an algorithm, a data structure, a state machine, a VLAN, a virtual machine, whatever it is. Once you finally actually implement it, things, at least for me, click. They just make sense, because maybe it's just that I'm a very hands-on learner, and I like to learn by doing. I don't learn by reading textbooks and listening to professors drone on and on. I learn by doing, and I'm a visual learner. So seeing someone else do it helps me, I guess, kind of get that basic understanding, but actually going through and doing it myself with the premise of that I'm doing it because I want to do it is really what helps me drive home these concepts and help me learn these things a lot better. And quite honestly, I don't even necessarily know if like state machines was like a huge like trip up point for me back when I was learning about them, but just like this little experience over the past week or so, trying to implement them in this one scene, and there will definitely be plenty more where this comes from as far as state machines go. I feel like I just have a deeper and better understanding of how they work, because I've actually implemented them and had to actually use them. So let that be, I guess, another tip for anyone out there trying to learn computer science, software development, IT, anything like that. I would highly encourage you, if you're learning a concept, whether you're going for your CCNA or you're going for your computer science degree or whatever the case is, take those concepts that you're being taught, whether that's through online lectures, in-person lectures, textbooks, whatever. I would highly encourage you to find something you're interested in, keyword that you are interested in, that will implement the thing you're learning and do that. Because if you're just trying to implement something because you have to and it's not something you're interested in, chances are you're not going to enjoy it as much and won't get as much out of it. But if you're, say, making your own video game and you want to get better at graphics, so you want to make your own video game, that's an excellent way to go about doing it, to learn graphics rather than going through some, lab or something on some online tutorial that you really don't care about. So that's another tip for you. So I feel like this one is this episode surprisingly had a lot of little tips and tidbits in it. But also, speaking of little tidbits and tips, if you have listened to the podcast for long enough, you probably already know the answer to this week's trivia question, which I guess we probably ought to get back to as this podcast comes to an end. And this week's trivia question, of course, as you'll recall, is what is the act of altering or manipulating data during transmission to gain unauthorized access or cause damage? And if you said a man-in-the-middle attack, you are correct. So congratulations. I know we've definitely talked about man-in-the-middle attacks before, so hopefully most of you got that question correct. Or maybe you're just a cheater and have a cybersecurity background like me, and this is your first episode, in which case, welcome, and I'm glad you got an easy one on your first episode. And if you did get this trivia question correct, or if you enjoyed the episode, I ask that you give it a rating and review, share all that stuff, because this episode, as I kind of mentioned, I think had a lot of good tidbits in there for like little tips and stuff. So I feel like there's a lot of people that could potentially benefit from it, especially at the end here for software developers. So be sure to do that. And if you have any questions about this episode, or you have topic ideas for future episodes, or just any kind of feedback in general, you can send me an email at contact@darkassassinsinc.com. There is a link down in the show notes below for that. And that is going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.